Okay, so that is it. So those were the 3 chapters on magnetism that you should have done. Then there is the next chapter, that is AC. So the next what we can do is we will be working with AC. So once we are of course AC is there, and then electromagnetism is there. Both of them are very interesting chapters and very different chapters. So quite a few have been asking doubts. Good, good. Keep reading and keep asking. Whatever doubts you have, mention there. I will be happy to answer them. As of now, morning I had answered most of the queries, and then I saw that even now there are a few questions which are there. So good, good. So there are 2 things we can do. We could take a break now, and then break as in we can just sit and solve some more problems, or we can do AC and then solve more problems. So I will do AC and then we will solve more problems. Okay. So after AC, I will take a long break as in we will wait, and then we will solve a lot of questions, numericals, and then we will move ahead. So yeah, so that is where we will work. Okay, so good afternoon to you all once again. Yeah, I'll tell you everything. How many days it will take, what we will do, everything. So I hope all of you are able to listen here, and all of you are able to see what we are going to do. Yeah. So the next chapter that we have is alternating current. So with alternating current, we would have reached 1890 as far as the year of invention or year of discovery is concerned. Well, alternating current was discovered much before, but then again, we didn't have alternating current generators. So the whole concept of alternating current generators started around 1880, 1890 with the starting of something called as Westinghouse, George Westinghouse something. So, oh yeah, there was a company by that name in US which started the hydroelectric power plant, which got the deal to start the hydroelectric power plant across the Niagara Falls. So anyway, so let us work with alternating currents. Alternating currents will take us maximum 6 hours to complete, or maybe 7 hours to complete. Then after this, we will take another 3 to 4 hour, 4 classes of only numericals. Okay. So because a lot of numericals are also clubbed along with this whole concept of alternating current. So starting from today onwards, I'll start giving you some specific work which will need you to think and then work. So let's see how it goes. As far as the alternating current is concerned, it will take us about 7 hours to do. Alternating current is also very important as far as your your NCERT is concerned. In fact, except for a very small portion, nothing has been removed from alternating current. So there is only one small concept of wattless current which is removed. Other than that, nothing else is removed from this chapter. It shows you the importance. Those of you who go for engineering, whichever engineering you go for, you will learn a lot of alternating current there. So from that perspective also, alternating current is very important for us. Alternating current is a very simple current. So this is the current. This is an alternating current. Yeah, anything which alternates is an alternating current. This is an alternating current. So this is the output in your, you have those, this is the box CMF. This is what is known as the box CMF. So you have those inverters at home. Most of the inverters give you an output of this kind. They give you a box output. This is the sinusoidal EMF. This is what is the output from a proper generator. The government sends current as per this. So this is there. There are different waveforms. The cheaper inverters have this sawtooth waveform. There are two types of inverters. There are some cheap ones and then there are these costly ones. So the cheaper ones have this sawtooth output. Okay, so this is what it is. So let us see what we have in store for us to learn as far as an alternating current is concerned. An alternating current is symbolically shown this way. So this is how it is depicted. So this is an alternating current and this is a DC. In an alternating current, you have E0 sine omega t. If you remember the output of a generator, N, B, A, omega, sine omega t. So this is what is known as E0 sine omega t. This is what is known as the peak EMF. If you look at an alternate waveform, this is the alternate waveform. So this value here is E0 sine omega t. So that is the peak EMF. So this is the peak value. This is the peak value of the EMF. So that peak value is what is represented as E0 sine omega t. Okay, this omega is 2 pi into frequency. In India, they send 50 hertz. So you will get 100 pi there. So 50 hertz is the standard thing in India. Most across the world, it is around this much only. Okay, so we have an alternating EMF. This alternating EMF is connected to a resistor. This is a normal resistor. So you have E0 sine omega t minus IR is equal to 0. So you have E0 sine omega t is equal to IR. This is, we have applied Kirchhoff's law. Kirchhoff's law is universally applicable to closed circuit, open circuits, all kinds of circuits. So here I have I is equal to E0 by R sine omega t. So I say that is equal to I0 sine omega t. This is the peak current. So this is the peak current. This is the peak EMF. So if you apply a current of an EMF of this kind, there will be a current which could be of this kind depending on the value for R. Assuming R is small, so there will be a current of this kind. Right? Yeah. So if you can make some notes here, we will move on. Okay, okay. So good. 60 hertz here, we do it. After this, we will start chapters after a long time. So beyond, after this, we will only sit and we will prepare for the different exams. I will give you a lot of these board questions. And then I'll give you a lot of these JEE questions. We will solve a lot of JEE questions and then we will work with it. This chapter will take us up around a week's time maximum. Henceforth, all chapters except for optics. Optics will take us maybe 20 days to complete. But other than that, all other chapters will take hardly 3-4 days to complete. Now with this, you will, after completion of this chapter and optics, you will be in a very good position to prepare for your KVPY exam. Okay, so I hope this whole concept of peak EMF and peak current is understood. Yeah, okay, so if you get it, so I have alternating EMF. So that alternating EMF was connected to a resistor. This is E0 sine omega t. This is resistance is there, and then again the current is equal to E0 by R sine omega t, and then the EMF itself is E0 sine omega t. So this is the current. If you look at it, the average value of this EMF is the average value of sine omega t. Now the average value of sine omega t is 0. So the average value of this EMF is 0. How do you find out the average value? Average is basically summation xi by summation number of times. Yeah. So this is what I have to do. So when I work this out, it will look like this. It is integral E0 sine omega t dt divided by integral dt. The limits are from 0 to 2 pi. So when I find this out over one time period, this is how you write average. So over one time period, this will give you cos omega t. Cos 0 is 1, 2 pi is also 1, so 0. So the average of this is 0. So when I find out the current also, I0 sine omega t dt by integral dt, this will give you the average current, and this is also equal to 0. So average EMF is equal to 0. Average current is also equal to 0. Do you understand this? Yeah. Can you make some notes? Wrong choice of color. Never mind. This is E0 by R is the EMF, sorry, current. E0 sine omega t is the EMF. So this is the average value of EMF. That average value is 0. Summation and integrals are same. Okay. Then average value of current is also equal to 0. Yeah. The average value of EMF is 0. The average value of current is equal to 0. Then let's find out what is the effect of the current. So the effect of the current is equal to VI. So if I am talking about the average power, so average power is equal to integral VI dt divided by integral dt. So that will give me integral 0 to 2 pi. V is E0 sine omega t. I is equal to E0 by R sine omega t divided by integral of dt. So this I know is 1 upon time period. So when I integrate it from 0 to t, so I'll get average power is equal to 1 upon t E0 squared by R integral sine squared omega t from 0 to t dt. Do we understand this? Power is equal to V into I. Energy is VI dt divided by dt will give you power again. So the average power dissipated in the circuit can be found out as integral this value. So now I need to know how to integrate sine squared omega t. So when I integrate sine squared omega t, I can't integrate it as it is. So I convert it into 1 minus cos 2 omega t by 2, and then I integrate this. So when I integrate this, I will get 1 by 2 E0 square by R integral 0 to t 1 minus cos 2 omega t whole divided by 2 dt. Now when you take cos 2 omega t, its integral will be sine 2 omega t. Now sine 2 omega t at 0 is 0. Sine 2 omega t at capital T, that is 2 pi by omega cancel again 4 pi, so that will also be 0. So can I say this will become equal to 10 by 2 E0 squared by R, and then integral of dt, so half into t. So this will become equal to this much. So this t gets cancelled and it becomes equal to E0 squared by 2 times R. Yeah. So E0 squared by 2 times R is the average power. Yes. Can you please work it out? Power is energy by time. Vi is power. So Vi by integral dt won't give you the answer. So when will we complete 12th portion? We will complete 12th portion only after schools reopen. Till schools reopen, we will not be doing 12th portion. We will not be completing 12th portion. Okay, so here is the first value of average EMF. This is the average current. Average EMF, average current. Then average power. Power is equal to energy by time. Vi is power. So Vi dt is energy. By integral dt is power. So integral. So this is power. So this is the definition of average power. So average power. So average power, if I have to do this again. So average power is equal to integral E0 sine omega t into E0 by R sine omega t dt by integral dt 0 to t. This is equal to average power. Definition of average power. So I will, this is t. So 1 by t. This is E0 square by R integral sine squared omega t dt. Now you can't integrate it this way. So the way you integrate it is by converting it into a cos function. So you will get 1 by t E0 square by R integral 0 to t 1 minus cos 2 omega t by 2. Okay. So this gives you E0 square by RT integral half dt minus integral cos 2 omega t by 2 dt. Okay. So that will, this will give you 1 by 2t because 0 to t. Now this part will be equal to 0. So remember, integral of cos squared omega t dt is equal to 1 by 2 integral 0 to t sine squared omega t dt is also equal to 1 by 2 sine omega t is equal to integral 0 to t cos omega t is equal to 0. So these values are 0, these values are half. Here in this chapter you can say WKT, we know that. When you do integration, I think these are there in your textbook, so you will be working on that. So from here what I'll get is that the average power is equal to E0 square by 2 times R. If you understand this, we will continue from here. These are given, you don't have to use these in your exams. I know it, so I am working it. In your exam, you can write this step, after this step, you can write this step, after this step, directly you can write the answer. So this is equal to E0 square by 2 times R. So you can directly write the answer. Okay. E0 is the peak EMF. Don't worry, Senthil, we'll have a lot of time. We will do. Yeah, after this chapter, I'll only sit and do revision of each of the chapters that we have learned. Okay. So why are the limits? We are trying to find out the average power over one cycle. We are trying to find out the average power over one cycle. Okay, the average power over one cycle. This is what we are trying to find out. So one cycle is one time period. So we are trying to find out what is the average EMF, what is the average current, and what is the average power. So while average EMF is 0, average current is 0, average power is equal to E0 squared by 2 times R. Where what is E0? E0 is the peak EMF. E0 by R is the peak current. R is the external resistance. R is the external resistance. So this is what it is. Okay, so this is what it is. Yeah. Yes. So I hope this part is understood. Now, if you understand this part, we will progress from here. Yes. No, by T I meant phase of 2 pi, but the time of one time period. A phase of 2 pi, but time period of 1. Okay. Yeah. So we will do revision on all. We will do after this chapter. We are going to just sit down and then work out NCERT model questions, NCERT. So we will do that only. After this chapter, we will do that only. So EMF is equal to this much. Now, if you understand this, then I will move on. So what you have is, here there is a quantity whose average value is equal to 0, but the effect of the quantity, the heating effect, is not 0. Yeah, so here there is a quantity where the average value of current is equal to 0, the average value of EMF is equal to 0, but the heating effect of the current is not 0. Okay. In such situations, we talk of a new quantity called the RMS value. Yeah, in such cases, we talk of a new quantity called the RMS value. RMS stands for root mean square. So if you look at physics, there are 2 points where we talk of. One, we talk about this in the case of velocity of a gas. So simple question for you, this is a table. I have a cylinder here. The cylinder contains gas particles. So I'm asking you, what is the velocity of cylinder? You will say it is 0. I further ask you, okay, so what is the velocity of the gas in the cylinder? You will say it is equal to 0. But if I ask you, what is the kinetic energy of the gas in the cylinder? You say it's not equal to 0, it is something. It has some value. Okay. So depending on the gas, we can say something. So this is a particular situation where again, we talk of a RMS velocity. So we have the average quantity velocity 0, but the average effect of the velocity is not equal to 0. Yeah. Similarly, we have a situation now where the average value of EMF is 0, the average value of current is 0, but the effect of that quantity, that is the heating effect, is not equal to 0. It is equal to E0 square by 2 times R. So under these circumstances, we use a new quantity called the RMS quantity, or R new value, not a quantity, it's a new value, which we will call the RMS value. Okay, so if you can understand it, then what is the velocity of the gas? Velocity is change in displacement of time by time. So because the container is closed, the velocity of the gas in the container is 0. Yeah, I don't know what do you mean by PDF of these slides. If it can be possible, I'll give. I have no issues. Yeah. This is the 8th slide. So the average power over one cycle is equal to 0. So here there's a quantity whose average value is equal to 0. EMF is less than, average value of EMF is 0. Average value of current is 0. But the effect of the quantity, that is the heating effect, is not equal to 0. The heating effect is equal to V squared by R is not 0. So EMF is equal to E0 squared by 2R. So if you have a container which is fixed, which is not moving, so the velocity of the container is 0. So the velocity of the gas in the container is 0 because the gas is also not moving. The gas is there where it is. But the effect of the velocity in terms of its kinetic energy is not equal to 0. So in all these cases, we have something called as the root mean square value. So we look at the root mean square value. Okay. So what I am going to do now is not required for your NCERT. So let me just write it in bold there. Not required. Okay. So the definition of RMS is root over of mean of square. Okay, square of that quantity, whatever quantity you are talking of. So if I have, we can do this for both the discrete functions and continuous functions. Actually for discrete, it will become summation. So this is summation. Okay, let this be this root over of summation of n square by n, number of numbers. Okay, so this is for discrete quantities. This is for continuous quantities. A simple question that they can give you, they can ask you to find out the RMS value of -1, 1, 2, 3, -2, -3, 0. So RMS is root over of mean of 1, 2, 3, 4, 5, 6, 7 square 1 plus 1 plus 4 plus 4 plus 9 plus 9 plus 0. So 9 plus 9, 18, 22, 22, 30 is the RMS value of these numbers. So this is a question which has appeared in your exam. Those days the exams were a little bit more easier than what it is today. So there you would have these kinds of questions. Okay. So if you understand the definition of RMS, I will teach you how to work out the RMS. Okay, my dear friends, you please add it. I don't know. I can't see half of what is there on the board. I can't see. So I'm just adding approximately. It seems it will be 28. I agree with it. So it is root over of 4. So the value is 2. I agree to it. No issues. No issues. 9 plus 9 is 18. This is 10 here. 10 plus 18 is 28. Root 28 by 7. Root over of 28 by 7 is root over of 4. So the RMS value will be equal to 2. Perfect. I have no issues. You work out. You work out. Yeah. That is always fundamental rule. Don't copy my notes. Okay. So if what I said is understood, then let's do the first question that we want to do. Find the RMS value of E0 sine omega t. Okay, RMS value of E0 sine omega t. So the RMS value of E0 sine omega t, that is represented as ERMS, is equal to root over of integral of E0 squared sine squared omega t dt divided by integral dt over one time period 0 to t, 0 to t. So already we have done this. The integral of this is 1 by 2. So it is root over of E0 squared into 1 by 2t by t. So that is equal to root over of E0 squared by 2. So that is equal to E0 by root 2. So this is equal to ERMS. That is equal to 0.707 E naught. Okay, so here I have used the definition of RMS to get it. In your case, it is very simple. You know that the average power dissipated is equal to E0 squared by 2R. So this is equal to E RMS square by R. So comparing, you will see that E RMS square is equal to E0 by 2, implying that E RMS is equal to E0 by root 2. Okay, so the simple question you will get in your exam is show that the RMS value of current is equal to 0.707 I0, or the RMS value of voltage is equal to 0.707 E0. Okay, so this is a simple thing. So please take some time, please work with your hands, and please make sure that you are getting this. So that is why I said this is not required for NCERT, because in NCERT we'll simply answer it this way. So this is the way you will do it in NCERT. That's the definition of ERMS. We can't talk of average. Whenever average becomes 0, we can't talk of average. In such situation, you talk of ERMS. So the power output. So you may write down the power output, power loss is equal to ERMS square, that is V squared by R, right? For DC, it is V squared by R. For AC, the definition of power loss is ERMS squared by R. So this is equal to E0 squared by 2R. So comparing between them, we will see that ERMS is equal to E0 by root 2. Okay, so I knew that question will come up. Why is it ERMS? So this derivation becomes important for us. So we should know how to calculate the ERMS. So they have said all those cases where the average becomes 0, but the impact of that is not equal to 0. We will talk about the RMS value. So the RMS value is E0 by root 2. So once you know the RMS, so we will write. So we can just write down that power loss. Power loss is equal to ERMS into IRMS. Okay. So now we can't talk of average. So there are two types of power loss. So there is an instantaneous power loss. The instantaneous power loss. So instantaneous power loss is equal to E0 sine omega t, I0 sine omega t. So that is equal to E0 I0 sine squared omega t. This is the instantaneous power loss. Then this is a variable. So we can't talk of anything but an average power loss. Now when we find out the average power loss, it is equal to E0 square by 2 times R. Okay. Now to define average power loss, we are saying that is equal to ERMS into IRMS. So from there you will get that ERMS is equal to E0 by root 2. IRMS is equal to I0 by root 2. I0 is the peak value here. E0 by E0 is the peak value here. I0 is the peak value here. Okay. So either way, this is what it is. Yeah. So you may make a note of this so that you will be able to understand. Yes, Videsh, that's what I tried to explain to you. If the average value is 0, we will just say 0, 0 and go home. But we are seeing that the power is not 0. So the significance of RMS is it tries to explain to us. So I am not able to understand that the average is 0, but how is there a power loss? So there is an error in our understanding. So in all such cases where the average is 0, but there is a power loss, scientists have told us, okay, there is some error that we are making in our understanding. So that error can be removed by talking about an RMS value. So the significance of RMS, it tells me that look, why is there a power loss when a AC current is passing through a resistor? Otherwise the power loss should have been 0. The derivation is not required. What I said is not required for NCERT is this derivation. This derivation is not required. This is not required. This derivation is not required. So you approach CBSE by simply saying that power loss is equal to ERMS into IRMS. So that will be the first line. So once you have that line, then you can start working on it. Okay. So here was the first question. What is the RMS value of E0 sine omega t? And you all found it. Okay. Next question I can give is what is the RMS value? Please work it out. Don't just assume that sir has already told us. What is the RMS value? What is the RMS value of E0 cos omega t? what is the RMS value of E0 cos omega t. So the RMS value will become E RMS is equal to root over of integral E0 square cos square omega t dt by integral dt. Okay, so now you have to perform this integral. So again, now this will become equal to cos 2 omega t minus 1. Okay, cos 2 omega t minus 1 by uh, cos 2 omega t minus 1 by 2. So now when you work this out, the integral for this will become sine. The integral for this will become 1 by t. Yeah, so again the tt will get cancelled and everything will happen, and you will ultimately get this is also equal to E0 by root 2. So whether it is cos omega t or sin omega t, it is equal to that much. We don't care for the negative sign. It is not this, it is plus 1. So cos square omega t, cos square omega t, cos square omega t is equal to by 2 plus 1. So when I integrate this, sine integral, when I integrate this, I'll get sine 2 omega t. For 0 also it is 0, 2 pi also it is 0. So here I'll get 1 by 2, and then ultimately I will get this. If this value is understood, then we can move ahead. So how did we know that we have to, how do we know that we have to talk about RMS value and not some other value? Well, whenever the 0, so we said in velocity case it happens. I'm a teacher, I'm telling you, my dear student, when the value becomes 0, but the effect of that is not 0, we will talk of RMS. Suppose you read the whole day in the evening, I gave you a grand test, the grand test everything became 0. But that doesn't mean you didn't do anything. So when I look at the value of it, you would have done something, just that the effect is not showing. A bad example, but there was an example. So as a teacher, I'm telling you, here it is, look at it here, look at it here. But as a teacher, we have to look at it. That is what is the most important thing. Okay. So if this is understood, so we talk of RMS in two cases. We talk of RMS velocity, we talk of RMS current. In case of alternating values. Okay, so I hope this is understood. Now, this is understood, then I have a third situation. E is equal to E1 sin omega t plus E2 cos omega t. Find E RMS. So I'll go back to my definition. My definition is root over of E1 sin omega t plus E2 cos omega t the whole squared dt by integral dt. Now this will give me E1 sin squared omega t plus E2 cos squared omega t plus 2 times E1 E2 sin 2 omega t dt, whole thing by t roots. Do you understand this? I just removed the brackets. So now I know this value is by 2. I know this value is also by 2. And I know this value is 0. Integral of sin 2 omega t will give you cos 2 omega t. Cos 2 omega t, when I put 0 and t both will become 1 1. So 1 minus 1 is 0. So this is what I will get. So it is equal to root over of this much. So it is equal to E1 squared plus E2 squared by 2 roots. They are only bothered about the answer because this is an entrance question. So this is the question and this is the answer. This is the question and this is the answer. So will this kind of, no, I first itself I told you this will never appear in your board exam. So on what basis did they find something as RMS value? Well, the logic is very simple. Where do you talk about RMS value? So suppose I give you a few data points. I give you a few data points. Uh, let's say this. I mean, no, this is not a bad example. Okay, I'll tell you. This is a coordinate axis. Suppose they give you a few data points like this. What will be the average of these values? Do you see somewhere? 0? Huh? But when you do the square, what will happen? When you do the square, suppose x values. So these points will vanish, they'll come up. Now you can get an average. So that is the logic for RMS. If I take a sinusoidal value, for every positive value, I have a negative value. So if I take an average, doesn't make sense. So what are we doing? We are just squaring them. So when we square them, the graph becomes this. Then we take root over. Now the average makes some sense. So that is basically what is happening. Okay, when you were looking at current, current individually looked like this. When you were looking at voltage individually, it looked like this. Now when you're looking at power individually, it's looking like this. Why? Because it's a product of those two. So when it's a product of those two, this product is not getting cancelled, but these two were getting cancelled. For every positive value here, I have a negative value here. For every positive value here, I have a negative value here. Okay, so that is why I am not trying to calculate what the average of it is, but I am trying to calculate what the average of the square is. So that is what makes sense, because that is not totaling up to 0. Okay, in other words, we are trying to find out the deviation. Okay, so please explain the integration of EC1 E2. Okay, no problem. No problem. My teacher told me only one thing. My teacher told me that, look, I am not interested in you getting into IIT or NEET. You are only interested in you getting into IIT or NEET. Do you understand this? E1 E2 sine 2 omega t, because we have 2 times sine omega t into cos omega t. So it becomes 2 times, so it becomes a sine 2 times omega t dt. Now 0 to t. Now when I integrate this, I'll get E1 by E2 cos 2 omega t by 2 omega within limits 0 to t. Okay. So forget about this. I look at this. So it is cos 2 omega into capital T minus cos 0. Yeah. How much is omega? Omega is 2 pi by t. So it is cos 2 pi by t into t. T cancel. So it is cos 4 pi. Cos 4 pi is how much? 0, 1. So 1 minus 1. So how much is 1 minus 1? 0. So moral of the story, integral of sine omega t is equal to 0. Integral of sine n omega t is also equal to 0. Integral of cos omega t is also equal to 0. Integral of cos n omega t is also equal to 0. Okay. Now you don't like this because you say, sir, what is all this nonsense? So I can say, okay, this nonsense is fine, but let us see. This is sine omega t. Yeah. This is cos omega t. So we are learning for every positive, sorry, for every positive there's a negative, for every positive there's a negative, and so on. Yeah. Now this is cos n omega t. Cos n omega t means what? Within 2 omega t, within this 2 rounds will be over, right? So it will become like this. So within this 2 rounds will be over, but still the graph looks the same. Yeah, just that the frequency will be increasing. So this will get compressed, the frequency will be increasing. So as long as there is a positive, negative, the average will always be equal to 0. So that is what we said. That is what, where did we say? That is what we said here. The average is equal to 0. Is that okay? Can you work on it? Please work on it. Please write down some notes for yourself. Think, imagine. That's the most important thing. Okay. So let me look if there are any other queries. Yeah. Explain the integration. Explained. Slide 13 once more. Okay. Slide 13 once more. Slide 13 once more. Okay. So now, if this is understood, the next question that I would give you is find the E is equal to E1 plus E2 sine omega t. Now find the, if you have understood whatever we have done till now, you should be able to give me the answer for this quickly, immediately. Find the RMS of E1 plus E2 sine omega t. Okay, slide 13 you wanted me to show. I showed you slide 13. I hope you are able to imagine this. Look, my dear friends, I told you that this integral is equal to 0. This integral is equal to 0. So now you don't like it. Why is he saying that this integral is 0? So I'm explaining to you that, look, if you look at the sine function, for every positive you have a negative. For every positive you have a negative. If you look at the cos function, if for every positive you will have a negative, for every negative you will have a positive, so the average will work out to be 0. But when you do sine square, square will look like this. When you do cos square, how will that look? It will look like this. So cos square will look like this. Now the average cannot be equal to 0. Okay, so the cube, if you do again, it will become equal to 0. Power 4 again, it won't be equal to 0. So they had an option of looking at power 4 versus square. So they said square is easy. So they said root means square. Otherwise, they would have said fourth root. Fourth root means fourth power. So that won't make sense. So this is what they said. Okay. So this graph is very important. When you have the sine n omega t, sine n omega t looks exactly like sine omega t. Only thing is that it is becoming shorter. So that's what we need to understand. Okay, so this also I hope all of you understood. Then I'm now asking E is equal to E1 plus E2 sine omega t. And I told you, tell me what is the RMS value for this. So let me check. So what is this? Let's see. Sir, we know the value for RMS. Okay. Then why can't we simply add both in previous question rather than working out the integration? That's why I had to tell you the definition. The definition, suppose I give you some function of time. The definition of the RMS value is root over of mean of the function. So mean of the square of the function. So you have to do the square of the function by integral dt. So this is the definition of the RMS value of this function. So they did not define RMS value as you take by root 2 and all that stuff. That is not, that's the incidental. Incidentally, when you apply this for E0 sine omega t, you got E0 by root 2. When you got E0 cos omega t, you got E0 by root 2. Okay, but that doesn't mean, so for E1, E2, E2, that doesn't mean for E1 sine omega t plus E2 cos omega t, you will get the same thing. So that's the whole concept of function, bro. So function is different. But I would still like to talk about this because I know a little bit more than what I'm showing you guys. So I don't show. So here it is. So here it is E1 sine omega t plus E2 cos omega t. I am a maths student and you have given this to me. So I'll say, okay, So this appears to be E0 cos theta into sine omega t plus another E0 sine theta into cos omega t, where E0 cos theta is equal to E1, E0 sine theta is equal to E2, then I square stuff, then I get E0 square is equal to E1 squared plus E2 squared. So I can write this is equal to, root over of E1 squared plus E2 squared into sine omega t plus theta, phase difference. Yeah. Now, what is the RMS value for this? By root 2. So that's what we said. E1 squared plus E2 squared by root 2. That's what we said. Okay, so that is where science is beautiful. Science is beautiful because you can approach it from a maths perspective, you can approach it from a drawing perspective, you can approach it from a physics perspective. So, yeah, so that's the beauty of science. Yeah, moral of the story, my dear friends, don't look at science's formulas. The whole problem comes, difficulty comes, people don't understand physics because as a teacher, it is easiest for me to teach you physics as formulas because there is no question asked, there's a formula. So there's no question asked, there's a formula. I can tell you the derivation of the formula also, but that is a formula. But the problem is when you get a question, a numerical, it becomes difficult for you to think in terms of the formula. But in terms of pictures, in terms of maths, in terms of trigonometry, if we start working, slowly our mind capability will develop. Okay. So I can ask you very simple, a force F1 cos omega cos theta plus another force F2 sine theta. What is the resultant of these two forces? Especially, okay, this is not a good question, but there will be some cases I'll explain to you where you will get a similar thing again. Okay, so yeah. So my whole aim is, I hope you are able to understand something. Okay, so that there is a lot more than just the addition happening there. So these are waves. These are these are waves. So we are talking of addition of waves. So we are talking about the principle of superposition. Yeah. Okay, so if you guys understand, oh, you were giving me the answer for the question I asked. Okay. Okay, good. Ashwin, good. Soumya, good. Okay, very good. Videsh, okay, excellent. Okay, good. Very happy. Very happy. So you have E0 plus E1 sine omega t the whole squared integral dt by integral dt. So I'll get E0 squared, the RMS value will be E0 squared plus this will become E1 squared by 2, fine. Then I'll get a 2 times E0 even sine omega t, that will become 0. Don't worry about this. So that's it. So it becomes E0 squared plus E1 squared by 2. So which you may write it as 2 times E0 squared plus E1 squared root over by root 2. So this is the RMS value for ERMS, where E is equal to E0 plus E1 sine omega t. Okay, all these are questions which have come in a JEE paper before. Okay, different combinations have come in a JEE paper before. So yeah, so my whole idea was to explain to you the definition of RMS and show how to apply RMS. If this is understood, we can move ahead. If you all have questions, you are free to ask. I can wait for some time. Yes, any questions, anything? I can wait for some time. Okay, so if you get it, good. If you don't get it, we can, yeah, tell me, I don't mind discussing again. But the moral of everything that I've been trying to say is that if you have any function of time, the RMS value of that is root over of integral of time function squared dt by integral dt. Why do I use this? I use this because the average values are all around a zero. I mean, the values are all around zero. So the average is zero. It doesn't make sense to find an average like that. So knowing that for every positive value, there will be a negative value, there is no sense in trying to find the average. So we are squaring them. So we get this, then we find the average and then take the root over, saying that root over makes more sense. Okay. Now, there have been questions in the JEE Advanced especially where they have given questions of this kind. They've given you the slope of these lines. They have asked you to find out the RMS value for this. Okay, they have given you a sawtooth curve and they have asked you to find out the RMS value for this. So you have to find out. So the function of time. So the function of time that we are trying to say is that x-axis is time. This is whatever, E0 or whatever. So I can say the slope of this, right? So E0 is equal to m into t. So what should I do? I should find out integral m into t the whole square by this time, whatever this time is. Yeah, so they'll give you that time. So that time, then the root over for that. So that will give me the RMS value. So you're going to square this. You're going to square this, and then you're going to find the average. So dt. So this is what it will come. So it will come m square t cubed by 2. Now I have to put my limits. So when I put my limit 0 to t, so that it will become m t by root 2. So here it works out to be mt by root 2. They'll give you a function, whatever be that function. So then you can find out. No, integral, I'm making a mistake. It's mt by root 3. Root over integral of t squared dt is equal to t cubed by 3. So by 3. So it is root 3. So the RMS value is somewhere here. Okay. So RMS value will become 1.732 by 3. So that will make it a little more than, so yeah, so you can find out. So 0.6, whatever. Okay. Yeah, so I'm good for today. This is all that I wanted to teach today. I will see you again on Monday and then we will continue. Those of you who didn't understand, watch the videos, but be sincere and honest. That's the only thing that will help you. Sir, how do AC, DC and DC to AC converters work? Yeah, that's what we're going to learn a little later. Does it have anything to do with the galvanometer? No, nothing to do with the galvanometer. We will study up to about step up and step down transformers, not generators. In this chapter only we will be studying. Yeah, we will be studying that. Slides, please. Okay. So the voltage we see in houses 220 volts RMS exactly. This is the first slide. Second, third, fourth, fifth, sixth, seventh, 8th, 9th, 10th, 11th, 12th, 13, 14, 15, nothing is there. 16, 16, 17, 18, 19, 20, 21, 22, 23. Yeah, thank you. Bye. Portion for this weekend test, I told you, no, I think it's a full chapter EMI. Yeah, second test. Yes. Okay, thank you. Bye.